Today we're going to be looking at what is a logarithm and properties of logarithms. This lesson is always kind of a little bit weird because it seems like, why the heck are we doing this stuff? The why of why we learned this is the next class. We use it to solve equations, but it's best if we don't try to shove all that into one day using the properties and solving. So just understand we're going to be doing things today that seem a little bit pointless. They will make sense as to why we're doing them next class. So it's good if you just learn the rules today, and then next class, when we solve, it will make more sense as to why. Okay? A couple things in this box here for you. A logarithm is set up as log base b of x equals y, if and only if it can change into an exponential equation over here, which we're going to talk about first. How to switch logarithms into exponentials and how to switch exponentials into logarithms. Okay? Natural log, this is a very basic definition. ln, the natural log, is the same thing as log base e. So they will never write it as log base e. They will always write it as ln. That is a specific button in your calculator, but it's just knowing what that is. Yes, sir?
What's E again?
E is the number 2.718, approximately. It's like pi. It's got a long decimal, but we just use that estimation of it. We have one more thing on that box right there. It's called the common log. Basically, this says if there is no base written on the log, it's an understood base 10. So log base 10 is how you would write that one. It's, again, never going to be written as log base 10. It's just always known that that's what it is. So an ln is always log base e. A log with no base is log base 10. Any issues with those? Just facts. All right. So then the first thing we're going to do is talk about how to switch a logarithm into an exponential and a log, or an exponential into a log. There is, and it's a little bit dumb, I've never taught it differently though, because the rules don't always make sense for this. There's a little loop trick for how you switch a log into an exponential. So when you switch this log, you start at the base and go around in sequential order. And by that I mean you start with base 4. That is your base of your exponential. The second number you pass on that loop is what number? 2. That's your second number there. So that's the exponent of the exponential. Is equal to the third number that you get to, which is what? The 16 right there. So 4 to the second power equals 16. Those are two equivalent forms. So a lot of times we don't know how to do a log. Like, none of us do logs of anything in our head, not including me. We just never have ever done that. But the exponential form should make sense to us. Those are the same things. So if the log doesn't make sense, often if you switch it into an exponential, it should. 4 squared is 16. Well, that we know. Okay? So let's try that again with this second one. Again, if I drew that loop starting at the base, to switch that into exponential form, where would I start? B to the what power? Fifth power is equal to 7. Like I said, right now, the why of this, like what the heck are we doing? It's not going to be there today because we're not going to solve anything today. But what we're going to do with this next class often is use this to help us solve. If we can't solve the logarithm, then we're going to switch it into an exponential and solve it that way. Okay? So same thing for number 3, only this time they're using an ln. So sometimes it's helpful for you to rewrite it. You won't have to do this, but just remember ln is the same thing as log base what? E. So if you need to write that out, you can before you draw your little loops so that you can write it in exponential form. In exponential form, you'd start with base what? E to the third is equal to C. Any issues switching a log into an exponential? Now we're going to go backwards. The good news is the same loop thing works. Okay, so the loop starts always at the base. So in question 4, what's our base? 2. So you draw the loop going just around like that. Same way it was before. Only this time when we're writing it in logarithmic form, we do log base what number now? 2 of, what's the next number it passes? 1/8 is equal to -3. So once you learn the pattern of that loop, it helps you go from one form to the other. All right, in question 5, same thing. Start at the base, going around. We would write it as log base what? 10 of what number? 1 is equal to 0. Now, this is the one we said, if it's a log base 10, do you have to write the base 10? No. I'm not going to worry about this one. You may write it like this, or you may write it in the second form where it's just log of 1 equals 0. I don't care on that one which way you write it. The next one I do care. Okay? The next one, if I use my loop, we would immediately start by writing log base what? E of 12 is equal to A. However, we said log base E is the same as what? ln. This one I do care which way you write that. Mainly because if you have to type that into your calculator, typing a log base E can get a little bit funky. There's ways to type the E that are a little bit weird that you don't necessarily want to do. So you'd rather use the ln button. Okay. Any issues so far? On the back, we're going to get a little bit of a taste as to why we do this and how to use these to solve. On the back, if you were asked to evaluate some of these things without a calculator, like I said, none of us do logs in our head, including me. Okay, so what you can do is switch it into exponential form to see if that makes more sense to you. So if it's not equal to anything, we can say that it is equal to x or something like that because we don't know what it's equal to. I can then use my loop to rewrite this in an exponential form. So if I start at my base and draw the loop around, what exponential form would this be the same as in number 7? 3 to the x power is equal to 81. So this is now asking the question, 3 to what power gives me 81? Well, hopefully we know enough exponents to know 3 to what?
9.
Well, 3 to the 4th, right? Because 3 squared. If we think through our 3's, 3 to the 1st gives me 3. 3 to the 2nd gives me what? 9. 3 to the 3rd gives me 27. 3 to the 4th gives me 81. So my answer to this question is then that 4. Because you're using to the 4th power gives me 81. Okay? Some of these are easier than others. And some of us are better at certain exponents than others. So for example, like question 8, if I don't know what that is equal to, again, we'd make it equal to x and rewrite it using our loop here. This is asking 8 to the what power gives me what? 2. Well, this is going backwards. It's not going up in powers, it's going down, which means usually what kind of exponents do those involve? The fraction exponents. So sometimes I have to think the opposite way. If I was doing 2 to the what power gives me 8, that would be 2 to the 3rd, right? So if I'm going backwards from 8 to 2, it's going to be 8 to the what? 1/3, which is the same as a cube root. Okay? I'm going to skip 9 for right now, and we're going to go to 10. If I was doing the same thing on 10, this is a nice easy one for us. 5 to the what power gives me 1? 0. Anything to the 0 power is 1. Good. Now 11 is going to show us another log rule real quick. If I don't know what this is equal to, I make it equal to x. When I rewrite this in x, what is it going to look like? Five to the x equals 5 to the 8th. Well, this is a very easy question then. If the bases are the same, what's true about your exponents? They have to be the same. 8. This teaches us something we're going to talk about on the next page, which is if you have log base 5 of 5, what essentially happens to that? It cancels out and leaves you that 8 as your answer. Okay. Let's go back to 9 real quick before we move on. ln is the same as what? Log base e. So if you need to rewrite that as log base e before you do the loop trick to rewrite, you may do that. If I use my loop that's starting at my base e and going around, what's that going to look like? E to the x equals 1 over e to the 4th. So to figure out the answer to this one, I have to ask myself, what makes us do 1 over something? What kind of exponents? Negative exponents. After you know it's a negative exponent, it should be pretty easy because you see e to that exponent on the bottom. So what is the exponent that it's going to use for this one? -4. Good, because you see e to the 4th. To get it on the bottom, it just has to be a negative exponent. One more with 12, and then we'll flip the page and finish up there. 12 is asking me 9 to what power gives me 1/3. Well, this one's kind of tricky. 9 to what power would give me 3? A 1 over what? 1 over 2. Why 1 over 2? Taking the square root of 9 would give me 3. If I want it to be 1 over 3, then it has to be what? Negative also. So it'd be -1/2. Okay, we're going to talk about other ways to solve these for those that hate this right now, because there's always some people that are like, can't do this, hate exponents. There are other ways to solve these, other ways to figure it out, and we will talk about those. I'm not going to do the bottom 2 here. I figure we kind of had enough of this. On the next page, there is a formula called the change of base formula that we do not need anymore as long as you have one of the Inspire calculators, which I would say you definitely use mine for your test. The reason we have this change of base formula is mainly for the old calculators, which didn't have log base in it, so that you had to type it in a certain way, and that's as a division problem. So I'm going to skip this because we really don't need it. On the next page, we're going to finish up here with properties of logs. We're only going to use properties of logs in one way. Usually in Algebra 2, they teach you how to use these to expand and then condense. For the purposes of actually solving, there's no need to expand. So I'm going to skip that because if we don't need to use it to solve, I'm just not going to do it. So some basic properties here that we see. The first 2 are basically inverses of each other. One starts as an exponential with a base b. Basically, if the base here is the same as the base here, what is this property telling us? All of this does what? Cancels out and leaves us this m as our answer. It's the same thing in property number 2, only property number 2 starts with a log instead. If the log base and the base here are the same, what happens to all of that? Cancels and leaves you that m as the answer, or whatever the exponent is as the answer. The other 3 properties are the ones that tend to give us fits, and we hate logs. So we're just going to get a little practice with this. Basically, on these, we're going to go from this form on the right to the form on the left because I told you we're only going to condense, because condensing is what we do in order to solve. So basically, property 3 tells us if we have 2 logs that are separated by a plus sign, and those logs have the same base, we can condense this to 1 log with that base and do what with the pieces? Multiply them. Property 4 has basically the exact opposite there. If we have 2 logs with the same base and they are being subtracted, we can condense that to 1 log with that base and do what with the parts? Divide. And then property 5 is the whole reason we typically don't see logs with numbers out front, because if you have a number out front of a log, you can bring it back as the exponent up here instead of being out front. Okay? We're not going to do any of these proofs. So if you flip over I think it's even past the next page, the back of the next page. There's a lot of pages we're skipping here. We're going to use these properties real quick to condense. Starting right here on question 4. So these basic properties help us out when we don't know the answer to things and we don't have a calculator. So if we remember some of our properties, in question 4, what do we know when it's log base 5 of 5? They cancel, which leaves me what as my answer? Root 3. Okay, very helpful for us. Now, we get this stuff screwed up when we see something like question 5 because we immediately want to cancel. Question 5, we cannot immediately cancel because why? Because there's 2 logs in the exponent with a plus sign in between. So what we have to do is use some of our other properties to condense that back down to 1 log in the exponent before we can cancel anything. So I'm going to go out to the side or the top here, and we're just going to work with the exponent for a minute. So here's where we use our properties that we talked about. We have the plus property, we have the minus property, and we have the number out front property. When we condense logs, the first thing we look for is any numbers out front of logs. Do we have any of those in this one? Yes, we have a 2 out front here. According to that 5th property we just talked about, what can I do with numbers out front? Bring it back as an exponent of the number back here. So that's the first thing you're always going to do. Bring back those numbers as exponents. The second thing is to look whether your logs are separated by plus or minus signs. In this case, my logs are separated by what? A plus sign. That 3rd property we talked about, number 3 in that box, says if logs are separated by plus signs, I can condense them to 1 log base 4, getting rid of my 2 log base 4s that were there before. And what do I do with the leftover pieces here, according to that property? Multiply. So plus goes backwards and multiplies, minus goes backwards and divides. So if I'm multiplying those parts, I'm now multiplying 6 times what? 3 to the second, which is what? 9, and that gives me what? 54. Once I've collapsed that exponent back down to 1 log, now I can go back to this problem here. Now this is the same as 4 to the log base 4 of 54. Now what can I do with my 4 to the log base 4 right here? Cancel. Once it's only 1 log, I can cancel. And my answer to this whole thing is what? 54. Okay? We're going to do 6 and 7, and then we will be completely done. All right, so let's practice more of this condensing. Remember we said, what do we do first in condensing? Look for what? Numbers out front that can go back as exponents. So do I have that in 6? Yes. This 1/3 can go back as an exponent of what? 27. What is a 1/3 exponent? The same as a cube root. So if you want to take a minute here, you can also work through that and say that's the same as the cube root of 27. Well, do we know what the cube root of 27 is? 3. You might as well simplify as you go. Then we go backwards and say what sign is in between my logs here? A what? Minus sign, which means when I condense this to 1 log base 2, I cancel out my other log base 2s up there, and I do what with the pieces here? Divide. If I divide 48 by 3, what does that give me? Log base 2 of 16. Now, next class, we'll learn how to actually solve that. For now, we're just practicing condensing to 1. Any issues with that?
I just have a question.
Yeah.
Why wouldn't you take the negative sign and, oh, that's a subtraction.
Yes.
Okay.
Then you're good. All right. 7, our last one. What do we always look for first? Numbers out front. This one has a number out front of the entire thing. Okay, so what is it going to go back as an exponent of? all of it, it's going to go back here. We'll deal with that at the end. For now, let's deal with what is in the parentheses then. Now, when you have multiple signs, we haven't done any with multiple signs in between them. The rule is to work left to right. Okay? So where am I going to start inside this parentheses? The first two here. So let's just look at the first two and pretend that's all we have. Those first two, what sign do they have in between them? A plus. So when I condense this to 1 log base b, what do I do with my parts according to my rule? Multiply m times n. Now I still have this second part that I've ignored. And now we're going to keep going left to right. So now what sign is between these two logs? A subtraction. So when I condense this to 1 log base b, what do I do with the parts of these? Divide. So what's that going to make this? mn over p. We still have a 1/2 out here, which we can leave. Or we can write it as what? What's a 1/2 power? Square root of the whole thing, of the logs stuff. So that is log base b of the square root of mn over p. I would be fine with either of those two answers, honestly. Okay. The condensing is usually our least favorite part. But like I said, the reason we use it is so that we can collapse everything to 1 log so that we can solve next class. All right. Our homework, therefore, skips around quite a bit here. Okay? So, homework starts on page 335. On 335 and 336, we are doing the odds from 1 through 35. But that is because this is back to the beginning stuff where the first 6 problems, we're just using that loop real quick to write that out in exponential or logarithmic. So the first 6 questions should take you all of 30 seconds. All right, the rest of them shouldn't take you too long. On page 337 and 338, we are doing questions 2 through 10. And 19 through 26. Okay? So I'm skipping around to do stuff that we have done in class, not the stuff that we did not do in class. This will not be on your quiz next class, right? The only stuff will be the graphing exponentials and graphing logarithmics. And if you need that extra practice page, got it right here.